Hello everyone. In this video, we will understand what is differential equation and what is its classification. So, starting with the definition of independent and dependent variable. The variables to which values are assigned are called independent variables and the variables whose values are obtained corresponding to the assigned variables are called as dependent variables. For example, y is equals to sin x, where x belongs to minus infinity to infinity. Here x is my independent variable and y is my dependent variable. Another example, z is equals to sine of x plus y, where ordered pair xy belongs to r cross r. Here x and y both are my independent variables and z is my dependent variable. Now, the definition of differential equation. It is an equation containing derivatives of one or more dependent variable. With respect to one or more independent variable. For example, dy by dx plus y is equals to e to the power x. Here y is my dependent variable and x is my independent variable. So in this equation we have only one dependent and one independent variable. Another example, d square y by dx square plus y is equals to 0. Again we have only one dependent and one independent variable. Another example, partial derivative of z with respect to x plus partial derivative of z with respect to y is equals to x plus y. Here note that we have only one dependent variable but we have more than one independent variable. So in this example we have only one dependent variable and two independent variables. Another example, dx by dt plus dy by dt is equals to x plus y and dx by dt minus dy by dt is equals to 0. Here note that we have two dependent variables in both of these equations and only one independent variable. In this equation, in this third example, we have two independent and one dependent variable, but here we have only one independent and two dependent variables. Now let us move to the classification of the differential equation. Firstly, we will classify the differential equation according to its type. So classification according to type of differential equation. The first one is ordinary differential equation. Differential equation containing only ordinary derivatives or we can say differential equation having only one independent variable is known as ordinary differential equation, and the second type is partial differential equation. Differential equation containing partial derivatives or we can say a differential equation having more than one independent variables. For example, dy by dx plus y is equals to ex. this is my ordinary differential equation. We can write it as ODE, and partial derivative with respect to x plus y is equals to 0, and this is my partial differential equation, because we are having more than one independent variable. Here we have only one independent variable. Now we will classify the differential equations according to the linearity. Ordinary differential equation. Since this video is dealing with only the ordinary differential equation, so I will classify the ordinary differential equation only according to linear differential equation. A differential equation is called linear differential equation if it is linear in dependent variables and their derivatives. Now you may find difficult to classify the ordinary differential equation with the help of this definition only. So there is one more definition. We can say a differential equation is linear if it satisfies the following properties. The first one, that dependent variable and its derivative have power only 1. The second one, there is no product between dependent variables or its derivatives. The third property says that it should be and the third property says it should not contain any non-linear function of dependent variable or its derivatives. Now let us understand this concept with the help of an example. Example number 1. d square y by dx square plus 2 times dy by dx plus x into y is equals to 1. Note that here I have power 1, this also has power 1, and y is also having power 1. So the first property is satisfied. Second property says that there is no product between dependent variable and its derivative. None is present. The third property says that it should not contain any non-linear function of dependent variable or its derivative. So third property is also satisfied, implies this is a linear differential equation. The second property says, the second example, x cube into dy by dx plus y is equals to 0. Here derivative has power 1, y is also having power 1, and none of the property is violating, so this is also a linear differential equation. Third example, d square y by dx square into dy by dx plus y is equals to 1. Here note that I have power 1 of y and its derivative is also having power 1, its double derivative is also having power 1. But second property says that there should be no product between dependent variable and its derivative, but the product between derivative and double derivative exists, so it violates second property of linear differential equation, implies non-linear. This provided differential equation is non-linear. Next example, let dy by dx is equals to sin y. Here we can see that sin y is my non-linear function and the dependent variable is coming under the non-linear function, so third property is violated, implies this is a non-linear differential equation. I hope you have an understanding now that when we can say a differential equation is linear or not. So let us do some questions. Check whether the following differential equation are linear or non-linear. The first part says d square y by dx square whole square plus 3 into dy by dx plus x is equals to 0. Clearly we can see that double derivative is having power more than 1, implies the given differential equation does not satisfies the second property of linear differential equation, implies the given differential equation is not linear. The second part says 1 plus dy by dt whole square is equals to d square y by dt square. In this case, we will firstly simplify the given differential equation. So opening the whole square, it becomes 1 plus 2 into dy by dt plus dy by dt whole square is equals to d square y by dt square. So clearly this differential equation violates the first property of linear differential equation, implies given differential equation is non-linear. Next question. A into d square y by dx square is equals to minus 6 into dy by dt whole cube plus 9y whole to the power 4 by 3. To simplify this differential equation, we can do cubing both sides, and it becomes a cube into d square y by dx square whole cube is equals to minus 6 into dy by dt whole cube plus 9y and whole to the power 4. Clearly this differential equation violates the first property of linear differential equation. Therefore, the given differential equation is non-linear. Next part. Under root of 1 plus dy by dx whole square is equals to x square plus d square y by dx square. To simplify this differential equation, squaring both sides, it becomes 1 plus dy by dx whole square is equals to x square plus d square y by dx square whole square. So the given differential equation is non-linear as it violates the first property of linear differential equation. Next part. D square y by dt square plus sine of t plus y is equals to sine t. We can clearly see that the third property is violated. How do we write it? The dependent variable y appears in non-linear function, that is sine of x plus y Therefore, it violates the third property of linear differential equation, implies given differential equation is nonlinear. Last part, t to the power 5 into d to the power 4 y upon dx4 minus t to the power 3 into d square by dt square plus 6 into y is equals to 0. We can see here is that all the dependent variable and its derivative is having power 1, and none of the derivative and dependent variable are in the product form. Also, there is no term, also there is no non-linear function present in this equation. So clearly this differential equation does not violate any property of differential equation, implies the given differential equation is linear. I hope you have understood that when we can say a differential equation is linear or not. Please note that we have discussed only ordinary differential equations here. Happy learning!